how to calculate the resultant force of a system of forces in a two-dimensional case. Let us discuss with the problem. So here ABCD is a weightless rod which is subjected to four forces P, Q, S and T as shown in the figure. If the magnitudes of the loads P is 10 kN, Q 4 kN, S 8 kN and T 12 kN, calculate the resultant and mark the same in the respective direction with respect to the end A of the rod. So here it's asked to find out the magnitude, direction as well as location of the resultant force with respect to point A. Okay. So to start this problem, first we have to draw the free body diagram. Okay. So here the load P of magnitude 10 kN is acting in the second quadrant. So we can split this force into two force components. One along the negative x-axis direction 10 cos 45 degree and the other along the positive y-axis direction 10 sin 45 degree. Okay. So next the force component acting at point B, that is Q of magnitude 4 kN, is acting in the third quadrant. So we can split this force into two force components, one along the negative x-axis direction with a magnitude 4 cos 30 degree and the other along the negative y-axis direction with magnitude 4 sin 30 degree. Then the force component acting at point C of magnitude 8 kN, that is acting in the fourth quadrant, that can be split into two force components, one along the positive x-axis direction of magnitude 8 cos 30 and the other along the negative y-axis direction of magnitude 8 sin 30. Then the force component acting at point D, that is denoted by the letter T with the magnitude 12 kN, is acting in the first quadrant, that can be split into two force components, one along the horizontal direction, that is positive x-axis direction with the magnitude 12 cos 60 and the other along the positive y-axis direction with the magnitude 12 sin 60. Okay. So this is the complete free body diagram for the given case. Okay. We can calculate the magnitude of the resultant using this formula. R is equal to root of summation H the whole square plus summation V the whole square. So where summation H is nothing but the summation of all the horizontal forces acting on the system, summation V is the summation of all the vertical forces acting on the system. Okay. To calculate the summation H, we can consider all the horizontal force components acting on the bar. We can take the force component which is acting in the positive x-axis direction with a plus sign and the force components acting in the negative x-axis direction with a negative sign. Okay. So at point A, minus P cos 45, that is minus 10 cos 45. Next at point B, minus Q cos 30, Q value is 4, so minus 4 cos 30. Next at point C, plus S cos 30, S value is 8, so 8 cos 30. And at point D, plus T cos 60, T value is 12, so 12 cos 60. Okay, so on resolving this, we can get the value of summation H as 2.393 kN. Okay. So next we can calculate the summation V. To calculate the summation V, we can consider the vertical force components acting on the given object. So we can consider the forces acting in the positive y-axis direction with the plus sign, and we can consider the forces acting in the negative y-axis direction with the minus sign. Okay. So at point A, P sin 45 degree is acting in the positive y-axis direction. So P value is 10 sin 45. Next at point B, minus Q sin 30. so minus 4 sine 30. Next at point C, minus s cos 30, so minus 8 cos 30. Next at point D, plus t sine 60, so plus 12 sine 60 degree. So on resolving this, we can get the value of summation V as 11.4634 kilonewton. Okay. So we can calculate the magnitude of the resultant R using this formula, root of summation H the whole square plus summation V the whole square. So that is equal to root of 2.393 square plus 11.4634 square. So the resultant force value will be 11.7105 kilonewton. Okay, so this is the magnitude of the resultant force. We can calculate the direction of the resultant force alpha using this formula, tan inverse of summation V by summation H. So which is tan inverse of summation V value is 11.4634 and summation H is 2.393. So the result of alpha will be 78.21 degree. Okay. So now we have calculated the magnitude and direction of the resultant force. Since both the summation H and summation V values are in positive x and y axis direction respectively, gets located in the first quadrant with an angular inclination of 78.21 degree. We have to locate the resultant force with respect to point A. So for that, we can use the Varignon's theorem. So according to Varignon's theorem, summation of the moments of all the forces about point A is equal to the moment of the resultant force of all the forces. So this is Varignon's theorem. So if we calculate the summation of moments generated by all the forces acting on the object about any point is equal to the moment generated by the resultant force of all the forces about the same point. This is Varignon's theorem. So now we can calculate the summation of moment of all the forces about point A. So at point A, there are two force components, P cos 45 and P sin 45. So there will be no perpendicular distance between those force components and point A because those two forces are acting at the point A itself. So there will be no perpendicular distance between those force components and the point. So we can neglect those two forces while calculating the moment about point A. Okay. Next at point B, there are two force components. One is Q cos 30 degree. That force is passing through the point A itself. There will be no moment get generated by that force Q cos 30. Next, Q sin 30 force creates clockwise moment about point A. So the sign for the clockwise moment is minus. So Q sin 30, Q value is 4. So 4 sin 30 into the distance between the force Q sin 30 and point A is 1 meter. So next at point C, S cos 30 force is acting along the horizontal axis. So S cos 30 force is passing through the point A. So there will be no moment about point A due to the force S cos 30. And the force S sin 30 is creating clockwise moment about point A. So the sign is minus S sin 30, that is 8 sin 30 into the distance between the force S sin 30 and point A is 2 meter. Next, considering the force components acting at point D, T cos 60 force is passing through point A. So there will be no moment about point A due to the force T cos 60. Considering the force component T sin 60, that force creates anti-clockwise moment about point A. So the sign is plus T sin 60, that is 12 sin 60 into the distance between the force t sin 60 and point A is 3 meter. So the value of summation MA is 21.1769 kilonewton meter. Since the obtained value of the summation of moments of all the forces is with positive sign, the moment generated is in anti-clockwise direction. Okay. So now we can use the Varignon's theorem statement. Summation MA is resultant force of magnitude into perpendicular distance. Okay. So summation MA value is 21.1769. We have calculated the magnitude of the resultant force as 11.7105 into the perpendicular distance. So from which we can calculate the value of perpendicular distance between the resultant force and point A as 1.8084 meter. Okay. So now we can locate the resultant force about point A like this. The magnitude of the resultant force is 11.7105 kilonewton. The perpendicular distance between point A and the resultant force is 1.81 meter. If we want to locate the resultant force from point A horizontally, we have to know this distance. Summation MA is equal to R into perpendicular distance. So if we want to calculate this distance x, then we have to consider the vertical component of the resultant force. So about point A, the summation V gives anti-clockwise moment. We can have this expression like this. Summation V into the perpendicular distance between summation V and point A is x. So summation MA is 21.1769 kilonewton meter. Summation V value is 11.4634. So from which we can calculate the horizontal distance between the resultant force and point A as 1.8473 meter. And the angular inclination of the resultant force alpha is 78.21 degree. That's all about the problem.